Good afternoon, everyone, and thank you for being here so late on day 3. We have saved the best for the last, so I think we should get started. We heard about DC-MHS throughout the morning and early afternoon, and in this panel, we are going to actually go and talk about things which are beyond what we heard. So let's get started. We have a very distinguished panel here, so we won't go through the introductions. You guys know everyone. But one thing which I don't know is I don't know fun facts about each and every one of these gentlemen. So I want to start with Brian and go down the line, and please share one fun fact about you which nobody knows in the audience.
Okay, one fun fact about me is I can imitate a trumpet with my mouth, but I can't do it under pressure, so I can't share that with you guys.
Brian, you're a cool guy. You're not under pressure. You can try it.
Trust me.
Fun fact about me. First time I drove a car, I took out 3 mailboxes. Each mailbox was on opposite sides of the road, and I was 2 years old. I am a better driver now.
I have to admit that when I hear good music, I cannot stay still. Dance comes to me, and I have to just shake my body.
So do we have any video of you dancing on day 1, late evening? I think Rebecca and her band.
It's very likely. I don't know who took pictures.
I think we should post it somewhere. Jean-Marie.
Fun fact about me, that's not an easy question. So I'm pretty good at forgetting to go to bed. So because despite the fact I am an engineer, it looks like that I'm only good to fix issues during the night. And after 3 or 4 days, you might be seeing my face like these dogs which are losing their eyes and red eyes and all these kind of things. So that's not because I'm sick, but mainly because I forgot to go to bed way too often.
And I'll share one about myself. Many years ago, I talked myself out of a traffic stop by claiming that I couldn't read English sign. And, you know. So let's get started. I think we heard about this amazing work which the team is leading and everybody in the audience is contributing. One question which I always think about is, in these kind of systems, what are the use cases which we think are going to become dominant? So would love to hear from each and every one of you. Imagine we have DC-MHS systems running. What kind of use cases you believe are going to be dominant ones for these? You know, AI, ML, general purpose, whatever have you, enterprise. Would love to hear each and everyone's thoughts. Brian, can you go first?
From an Intel perspective, our idea around DC-MHS is having a common set of hardware where we're seeing the same systems run at enterprise as we see at edge, as we see at hyperscale, and then the same systems at Intel. Such that, you know, if a hyperscaler is seeing an issue, we should be able to quickly replicate that at Intel or with our enterprise customers. So that's the main advantage we see at Intel.
Yeah, okay, so Brian's given us validation and quality. From a Dell perspective, it's continuing the velocity. It allows us to do more. Tim Lambert was up here just in the previous panel and mentioned we have 50 different platforms per generation. We're dealing with CPU proliferation, which is great. We can pick the right CPU for the right job, but all of that is a complexity. From a Dell perspective, we look at it as, all right, let's simplify the things that are common within the industry, and let us refocus on the things that we are providing value in differentiation.
And from a hyperscaler's point of view, Google's point of view, it is great that we will eventually come up with solutions that are agile, as Shawn just mentioned, and are qualified. As Brian just mentioned, the individual components hardware components are qualified and are agile. They cover a breadth of techniques and technologies. What matters to us more than any of that is software compatibility. When I first joined Google, Sylvius challenged me and said, hey, you're a hardware guy, I'm a software guy, just do your hardware so that my software runs. That's all he was asking. To give him a hardware that software runs. So we went through the journey of decomposing that request into where is the management element that causes people pain, DCSCM. Where is the security element, DCSCM. Okay, so if we translate all of those into DCSCM and SmartNIC, maybe those two touch points we have covered in hardware make it kind of similar so people can design to the same thing. But then we need to run software on it. So the modular hardware system allows software guys to get a system quickly so they can start playing with it in software, basically BMC, OpenBMC, BIOS, UEFI, telemetry, test and validation, benchmarking. So all of those can be run now on common hardware, common in at least interfaces, so that they can debug their solutions faster. So that is basically the integrated solution that we're looking for, progression of DCSCM to modular hardware system to integrated systems such as DC stack. And eventually, we do have a cloud service model is another initiative within OCP that those guys are the ultimate beneficiary of all of our work.
Okay. On DHP side, I think the sustainability and energy efficiency are going to be the biggest challenges we will be facing during the next decade for the industry. And making match the hardware configuration with the software stack in every workload to reach this goal will be really critical. And we envision that there will be a need for a way much wider diversity of compute platforms. And the only one way to deliver that at a very fast pace is to break down the systems, which is coming from a monolithic approach with a single board to multiple components, offering the agility to deliver hardware at scale at a very fast pace, without requalifying every module each time we need to change something.
Awesome. So actually, these answers triggered few follow-up questions for me.
Have a seat.
That's okay. I can stand. Shawn, you mentioned about CPU vendor proliferation. You mentioned about software. So actually, the question I have, a two-part question. One, on the CPU side, how do we expect CPU vendors to develop some kind of reference designs? Is there a part of strategy? Maybe, Shawn, Brian, you guys can address that. And then I'll follow it up with a software question.
Okay, so we can have the ask and then we can have the answer, but ultimately, I mean, from a consumer of the HPMs, that's what we'd like to see, is that the CPU producers are responsible for the circuit board that is underneath their CPU. It's their CPU, it may be DIMMs that are there, it's the support circuitry, such as the VR, the voltage regulators. And then from there, as an HPM, then that's something that we can then take and then expand out around it. So that's the vision that we have, and that these HPMs are interoperable regardless of who is going to, whether it's Dell or HPE or Google, as an example.
Brian, thoughts?
Yeah, and just to add to what Shawn said, so at Intel, we put a ton of effort into producing design guides and reference platforms and the software, the firmware for these, and then they spend a ton of time in our labs, right? And we have hundreds of customers that will all do different variations on those reference platforms. And what we're finding is that as we do more, offer more products, and the complexity is going up. So now you have new technologies like DDR5, PCI Gen 5, you have TDPs doubling, all this complexity is going up. our view is that as the complexity increases, the platform complexity needs to decrease at an exponential rate, right? So these platform producers have a fixed number of resources, and they can apply those resources on these platforms that are taking longer to design, longer to validate. So our vision is that, if we get these platforms to look more similar to what Intel's producing, Intel offers those platforms for free. You can see 2 of them out in the expo hall. Customers, ODMs, OEMs, hyperscalers take those free platforms and bring them to market quicker without doing a grounds-up design.
Yeah, one thing I'd like to add to that, Brian's using the term platform. There is the HPM, there is the platform that's built around it, but one of the things that we see with DC-MHS is that it enables a new class of platforms. As we have our resources, our limited resources we have available, getting an HPM design that's industry validated, ready to go, then we can start putting our focus on other types of platforms that are new and exotic and solve new problems.
So in terms of, you mentioned about, diversity of CPU, what kind of strategy or thought process or roadmap or whatever have you in terms of expanding that within the DC-MHS? Any thoughts on that? Bringing new
Yeah, so I mean,
CPU
where
providers.
we started, this started back October of last year. The group of us got together, we started going through ideas, we set a scope. There was an expansive scope that we had back then to how much we thought we could accomplish. We had a time goal, we reduced the scope. So now, as we're looking forward, several things that were presented today that we're very excited about, taking DC-MHS to now solve problems with shared infrastructure, Open Rack v3 with the wider 21-inch racks, full inclusion of the quote 48 volts, so 48 to 60 volt solutions, and there are more ideas that are coming up.
I think there's also something important. So we are at the OCP Summit, and DC-MHS is an open work group. So it started with our 4 company, but we soon expanded the work group to AMD and other chip vendors. I think Ampere has made a request to join the work group. So this is exactly like DC-SCM. So it starts from an ID, it gets formalized as a V1 specification, and then it's open for discussion and improvement. That is also something which is important. So it's not a closed work group where we want to work only the 4 of us between each others, but really opening up the work group to define the new standard of modular architecture is really key for the success of the program.
Actually, another attribute that I have to credit to OCP, Open Compute Project, is the fact that for whatever reason, myself and my team and my company were thinking about these things out loud, perhaps, let's just say it that way. As we started talking about them, then here came collaborators from Dell and Intel and then HPE. On their own, they had similar ideas, but traditionally, they had not shared those things outside. But then once we all talked, we recognized that we were talking about the same kind of thing. A modular system that HPE has built into their systems, and modular systems that Dell has built into their systems, and Intel has created similar modularity. They were all modular systems, but they were done in different ways, different traits, different targets. Once we got together, we said, well, okay, they are very similar. We are part of Open Compute Project. Why don't we just outline things in the same way? We had Microsoft and Google, for example, were working on DC-XPI, if you remember. Last year we talked about it, an interconnect between what we call now HPM and modular I/O that we had. That definition was done, and we are actually going to production with that concept. But as we worked together with other teams, we saw that, oh, okay, A variation of that is being done at PCI SIG, and that's the one that the team decided to use because they thought that that would be more easily adopted. Okay, so for the sake of commonality, for the sake of increasing the volume and capability and qualification on these points, it did make sense for us to work together and come up with a common solution. So I'm saying that one as an example to address your question. Use cases are varied. It is very likely people are thinking about things on their own as we come out during the conversation today. And you probably saw that we talked about futuristic things, the type of things that we haven't done yet. But we start talking about them to get cohorts, people who recognize similar goals, to get together and eventually drive to the same direction.
Awesome. And as I mentioned, it was a two-part question. So coming to the second part, which both Siamak and Jean-Marie, you were referring to on the software side. Very interesting point. We have a hardware system which is open source and moving forward. And making it more usable very quickly will also require some amount of software stack running on it, which is open source as well. So quick thoughts in terms of what is the strategy there on developing that? Is it something which each of your companies is doing and plan to contribute it into some particular forum and have it work on DC-MHS systems? Or how do you think about that?
Regarding the software, so if you came to a booth during the CP Summit, so you probably have seen that we are adopting OpenBMC on our Gen 11 platform. So that's a great step forward, and I think for DC-MHS, that will be one of the reference software, management software we'll be using. I think what is critical for the next generation of the specification, there is always ways to improve things, but there is also needs to put some deadline. But it would be really to work on the authentication mechanisms between the modules for DC-MHS and helping the software to not automatically reconfigure, but at least discover what's connected to what and being sure that this is, I would say, a secure modules to start up and properly use it. That is definitely something we started to work on, or at least thinking about, and we will probably initiate some discussion with the work group. I don't know if this is going to be happening within the hardware work group by itself of DC-MHS, or if we need to create another sub-work group specific on the software topic, but that will be definitely a topic of interest on our side.
I totally agree with what Jean-Marie said. The work needs to be done. Software commonality is very important. We call collectively infrastructure software. That includes telemetry, security management, benchmarking even. Test and validation, more important piece of it. I'm sure every company has a suite of test and validation stress tests that they're running themselves. They're running that with their suppliers. And sometimes they ask their suppliers to run the test and validation suite before systems show up at a customer consumer's lab. Those things do exist, but they exist in their silos. They're different. They have been maybe homegrown for many generations. Every time you find a bug, you include a new test procedure to kind of catch that bug. And that is a collection of things. We've all done that. Now, what we should recognize is that, yeah, everybody needs that. We have done it, and new technologies, new systems, CXL or new processor or such will show up, and we all have to redo our test and validation suite based on the new technology. Once we recognize that, and if we are willing to share a little bit of code, a little bit of techniques of doing the same, we should have a similar test and validation setup. Now, which organization, which team should do that? We are perhaps as part of a server project, we are producing the hardware. But we recognize, we are architects, we recognize that software is important. Now within the OCP, we can say, okay, hardware management may be the right place, security project might be the right place, or maybe we need to create another one for this thing that, I don't know, we've been dreaming up as DC stack. That is the one that I keep mentioning it. Hopefully that it will catch some momentum and we bring some hardware and software guys together to eventually make it happen.
Awesome. Thank you. Yeah, go ahead, Shawn.
Well, yeah, I was just gonna. Siamak and I always poke each other with top down versus bottom up. So I'll give the bottom up. So we've got a hardware foundation now, and Jean-Marie, you were talking earlier about discoverable EPROMs for discoverability. Yeah, we've got the hardware foundation. We can start chipping away as we go up the DC stack, and eventually getting to a full ecosystem.
Perfect. In fact, you ended on the perfect word where I wanted to ask the next question. And Brian, you earlier referred to development of ecosystem as you were talking about reference board designs. So how does something like DC-MHS help ODMs and help in growing ecosystem? Any thoughts there?
Yeah, so one of the things that Intel's working on right now is sustainability, and sustainability is becoming a very important hot topic for people. We're working on carbon calculators for PCBs. If you look at a server, 50% of the embodied carbon in a server is the actual PCBs. So the idea behind DC-MHS is how do you, optimize each element of that server for low carbon and improve sustainability. And Intel's working with the industry to come up with those carbon calculators and help our ecosystem partners on, driving to their sustainability goals. I mentioned that Intel's also giving away those designs for free, where our OEM and ODM partners can either take those as is. There was an example from Jabil at the show where they took the Intel reference platform as is. Other customers can take those and innovate on top of them. But that's the idea behind the modularity, is getting it closer to that customer design and then just giving it away.
That's awesome. Actually, sustainability is very close to my heart, and this is music to my ears. And I do see that with modular architecture, you actually improve circularity of the design, which becomes very important. So, sustainability has become fifth tenet, and we can talk all day long on sustainability, but very quickly, as DC-MHS team starts putting specs into contribution, you'll have to start looking at ways to meet this tenet. So the question I have for all of us and for all of you is, what are your quick thoughts on how that tenet can be met by contributions made through DC-MHS? So let's say, because the sustainability team also is looking for ideas from folks like yourself. So anybody has thoughts on, like, these are the ways we should look at, and you talked about embodied carbon in the PCB as a very good example, but are there any other examples such as circularity of the design itself? Hey, this can be reused with more lifecycle extension, and that can be also considered as part of. So any thoughts there on how you would go about thinking of meeting a tenet like sustainability?
I think there is something important we can think about. When you look at a server, there are multiple parts which have different life cycles and life expectancy. And when you get the monolithic systems, it was extremely hard to reuse the different subsystems. So at HP, we are using the common power supply since a couple of generations, but with DC-MHS and the standardization of the power supply between vendors, so we can hope that we can reuse the same power supplies between different generations of servers. So like that, when a customer is going to upgrade its own infrastructures, he might not have to repurchase another power supplies when you will be replacing an existing systems. So we can envision the same kind of behavior with DC-SCM modules, for example. So the BMC infrastructure is no longer soldered down on the motherboard. So when you are going to upgrade your infrastructure, you just have to replace the chassis and re-inject the DC-SCM modules one way or the other. the ultimate goal would be that we design chassis which can last between different generations of systems, but then came up some kind of logistical aspect. How do you upgrade a motherboard from a chassis within a data center? So I think the whole industry really need to think about how do you want to upgrade systems? Are we keeping the approach where we decommission at rack levels? And if we decommission at rack levels, what happens to these racks? Are they going to come back later on into the data centers? Are they going to be scrapped? Are we able to recycle them properly? That's really key. And I think modularity is the right way to move forward, because this is giving way much more options to the end users on how to define when he wants to upgrade things and what kind of modules he wants to upgrade.
If you think about the problem in a natural physical way, a lot of times people want to increase performance and reduce the cost of providing that performance. So that could turn into some sort of an efficiency metric. A lot of people are already trying to do that, use the same amount of power but increase performance, do the same performance under less power, use less material to build the same part.
That's a good one.
If you build the part, build it by design in such a way that you can reuse it, and this modular hardware system, the word modular is the one to help. Generation to generation, you can, out of 5 components that go into a modular system, you can maybe standardize 2 of them that can span 2 generations. So that's a reuse in development, manufacturing, testing, validation. You know, validation takes a lot of power. It uses a lot of components, a lot of systems need to be a part of validation. So you eliminate all of those by the word reuse. Even across same space, the same generation, you can reduce the amount of material used. On top of all of that, modular systems allow differentiation on individual module. You, for example, have a system comprising of an HPM and a power supply. A company can come and produce a better power supply. What does better mean in that? Once we have a metric for what better is, better might be more power efficient, better might be less cost, better might be sustainable.
Right.
So once we have the metrics, you can challenge each other to do better every time.
So we are out of time, but I want to ask, we are all technologists here, and this is probably the most difficult question I want to ask. In 30 seconds, each of you, can you present a marketing line for DC-MHS for somebody who has no idea about DC-MHS to understand? No more than 30 seconds.
Yeah, for Intel, it's very simple. It's to prevent the customization and to create a more sustainable modular, right? So the idea is don't hyper-optimize to one segment or one chassis. Optimize for the whole ecosystem and reduce the number of offerings so that you can consume more from the CPU suppliers.
Yeah, so using from my perspective or Dell's perspective, using a building block approach, we can minimize the number of replication of things that are being designed, validated, deployed, and instead focus on a richer variety and creating new opportunities, new innovations, while having a very clean foundation that we're all using.
If I may add,
30 seconds.
If I may add a customer point of view to that, we have suppliers here, and customer point of view is a method. This modularity allows us to provide a way to describe our requirements better. Requirements being written down in a way that's futuristic. What is our future requirement, so that suppliers can build to them, test it on their own, and eventually deliver an agile system to us.
Quickly, I really believe that to address the energy crisis that we are all facing currently, we need to match the hardware configuration with the software stack and the workload that is going to be used on the hardware platform. And hitting modulars allow us as system designers to quick turn design and provide hardware solutions which are very efficient when looking at specific workloads. And that's the best way to save energy.
Awesome. And for me, the way I see DC-MHS is, I think it's the first time within OCP a hardware system has been developed with combination of many vendors coming together. I do not believe there is any other system. There are many systems contributed into OCP, but I think this is the first time you see so many vendors coming together, trying to put it together. So
Mr. Chairman, you didn't ask me this question, but I'm offering this.
we are already 5 minutes, and I'm supposed to go for another talk, and I'm running late.
I just have to share with you that I feel very proud to be amongst the set of people, not only people on the stage here, but set of people who put together DC-MHS. I have actually seen that they're experts. They are the best cream of the crop in the industry, come from strong companies with many, many years of experience and great architects and great designers. Very proud of that. Thank you.
Thank you, everyone. Thank you,
Thank you, everybody.
Thank you, audience.